Hello everyone. In this video, we talk about functions in Python. In both mathematics and programming, a function is a fundamental concept, but its specific definition can vary slightly between the two contexts. In mathematics, a function is a relation between a set of inputs called the domain and a set of possible outputs called the codomain, such that each input is related to exactly one output. It's like a machine that takes an input, performs a specific operation, and produces an output. Functions are often represented using notation like f of x, where f is the name of the function and x is the input. In programming, a function is technically a reusable block of code that performs a specific task or a set of tasks. It's a way to organize code into modular units, making it more readable, maintainable, and efficient. Functions in programming take inputs, arguments, perform operations, and return outputs. They help break down complex problems into smaller, manageable pieces. Therefore, it is critical to know how to use and define functions in Python. Okay, so now that we are done with the definition of function in Python, let us focus on two important pieces when you want to work with functions: input arguments and output parameters. Recall that functions can receive input arguments provided by the user or calling entity, and functions produce output parameters representing the results after completing their task. So this is very similar to the idea of domain and codomain when we talk about functions in mathematics. We have different types of functions in Python. We have built-in functions that we have seen a few examples of these so far. And the reason that these things are called built-in because you don't have to define them, and there are predefined functions in Python's standard library, and we do not need to import anything. For example, anytime you're working in Python, you can use the built-in function print, which prints a string, or you can use len, L-E-N, which gives you the length of a list or a sequence in general. Or we can use type, which gives you the type of any object in Python. On the other hand, we can define custom functions in Python. These are very helpful when you want to perform a specific set of instructions or tasks that are specific to your goals. And in this case, you can define your own function. And the way we can do this is using the def or def keyword. We can also have nested functions, which means that we have functions defined within another functions. This is kind of like a composite function in mathematics where you have functions where there are inside another functions. And also we have something which is very important for machine learning and data science applications known as Lambda functions. Lambda functions, you can think of them as anonymous functions. So it's kind of interesting, but you can think of these as functions that they don't really have names, but you can use the Lambda keyword to define them. And these are typically very helpful when you want to perform short and simple operations. And we're going to talk about these Lambda functions that are very helpful for data cleaning, for pre-processing data, and therefore we need to learn about them. But let's get started first with built-in functions, right? Like, for example, the len function, and this is part of the Python standard library and is available for user without the need for explicit import statements. For example, here we have a list which contains three elements. And if I use type here, it tells me that the type of this object is a list. And this is consistent with what we learned in the data structures lecture. Or if you have another list, which I call it 1, 2, 3, 4, With the square brackets, you can use len on this, or len, and you can see that we get 4 because there are 4 elements inside this list. But let's talk about custom functions, something that we need to learn to see how we can define functions on our own. You can define a function, as we mentioned earlier, using the def or def keyword. And here is the general syntax that you can use. So you use def, the name of the function, and then the input parameters or input arguments. So this is very similar to the idea of f of x, where f is the name of function and x is the set of inputs. Something which is very important but optional when you define a function is to explain what that function is supposed to do. And this is what is known as docstring or documentation string. So this is some text that explains the purpose of the function, and you use these triple double quotes. And the nice thing is that anything here inside these triple double quotes is like Python comment, meaning that the compiler does not look at these in terms of Python codes, and this is just for readability and conveying some information about what this function is supposed to do. And then after docstring, usually you have the function body, and this is where you put your code that you need to provide to perform some task. And at the very end, if you want to return some parameters, meaning that you want to have output parameters and your function is supposed to return some values, then you must use this return statement. So you say return, and then whatever the result is. So this is something that is very important because I see this very often that you perform some operations here and we don't use return, and you get to see that when you're using your function is not producing any outputs, and that's just because there's no return at the end. And it's a very simple kind of mistake, but something that happens very often. So let's start with the very first function that we want to define here. We use the def keyword, the name of the function. It should be something meaningful, like add numbers. In this case, we have a function that accepts 2 input arguments and add them together. And do not forget to use this colon here, right? That's important. So you use the def, name of function, input arguments, colon. And once you do this, I can show you this even here. When I press enter, I get this automatic indentation, right? So this is very important because in Python, we don't have any like end keyword. So we need to say, well, which block of code is inside this function or relates to this function that we want to define. And the way that Python understands this is using this indentation, right? So that's something very important to consider here, that everything that is supposed to be inside this function needs to be indented, as you can see here. And in this case, we start with a docstring, just some general information about this function. We perform some operation, add x and y, and assign the value to result. And at the end, we return result, right? So if I define these, and remember, right now, we are not really doing any sort of anything or any operations. We just define the way that this function is supposed to behave. And later on, when in the next cell, I'm saying that call this function, pass these input arguments, and save the result in any name you want. Here, I call it my result. And now we print, you can see that we get 5. So that's how we define it, and then we can use that functions. Remember that usually we have to follow some naming conventions, and similar to naming conventions for variables, it is recommended to use lowercase letters for function names. And also you can use underscore when you need to use multiple words. That's something completely legal or something that you can do. The other thing which is very important is about the type of docstring, right? So choosing the suitable type of docstring really depends on your personal preference and the level of information that you want to provide. So you can either use like a one-line docstring, right, which is only one line, or something which is definitely better and I recommend you to use is multi-line docstring. So the nice thing is that when you're using these triple double codes, you can use multiple lines and they're all considered as just text or comments, so they're not gonna cause any issues with your Python code. And in this case, you will have one line or one paragraph where you explain a detailed or provide a detailed description of the function. Then you have another section where you have args or input arguments. Here you explain what input arguments this function accepts and then returns, so what this function is supposed to produce. And even you can provide an example, right? Like, how can I use this function that I just defined? So these are very helpful, especially if you want to uh, ensure that other people can use your code conveniently, so they can read your documentation here and also know exactly how they can run your code. So this is a really good practice for programming. Something to keep in mind is that in Python, a function can return more than one value. And the way that it works is that the function returns a tuple, right? So remember when we talk about packing and unpacking using tuples in the data structure lecture? So if you assign multiple values to an object, Python will create a tuple. And this is, you can see that something that happens here. For example, we have this function and I call this calculate rectangle properties. So this function accepts length and width of a rectangle. And here you can see that we use the multi-line docstring. So we have these two arguments. And then in the case of what this function produces, we create a tuple containing the area and perimeter, right? So the area of a rectangle is easy, is length times width, and then the perimeter is 2 times length plus width, right? So you calculate these two values, and then you just say, I want to return area and perimeter. So remember that now because you're assigning two values to one object at the end, this will be converted to a tuple, right? So to show you how this works, let's run this cell to just define the function. Right now, we are not really performing these operations. This is just the blueprint or design of this function. Now, next, we're going to give the length and width values and provide these input arguments to this function. And we call the output result, right? And remember, result is a tuple. So if you want, you can unpack that, right? We know that the first element should be area, the other one perimeter. And then we can use these print arguments to print them. And as we expect, the area is 5 times 3, and perimeter is 2 times 5 plus 3, which is 2 times 8, 16. And just to show you, if I look at this result, you can see that the type of this result is a tuple, right? Because we return two values. So in this case, we actually get a tuple. And obviously with tuples, we can unpack them whenever we want. The other feature when working with Python functions is that you can provide default values for some of the function parameters or input arguments and making those optional when calling the function. You have already seen this. For example, when we want to do a slicing in Python, for example, for Python list, we know that we have the structure of a start, colon, and colon, a step. And we said that if we don't provide the step parameter, the default value is 1, right? So this means that when that operation was defined, somebody said that, well, the default value for a step is 1. But how can we define these default values? The way that we can do this is that inside these parentheses where you provide your input arguments, you can provide the default value. So this means that the default value for width is 1. If you provide another value, that will override this value. But if you do not provide width, it's going to be 1. And the same thing with height. So in this case, for this function, this means that length is the one that is mandatory, and width and height, they're both optional, right? And it's always a good idea to include this information in your Docker string to make sure that the other people that they want to use your code are aware of this. And in this case, we want to calculate the volume of a rectangular prism. And in this case, it's just length times width times height. And in this case, you can see that for the length parameter, we use the value of 4, right? And in the first case, we are not providing any values for width and height. So by default, they are 1s. And this means that the volume should be 4. But in the second case, right, we are using these non-default values of 2 and 3 for width and height respectively. And if I run this, so you can see that with default values, we get 4, and with custom values or dimensions, we get 24. Okay, so now that we learned about default values in Python, let's dive a little bit deeper into this idea of what variables functions have access to. And this is what is known as the scope of a variable. So what is the scope of a variable? It refers to the region of the code where the variable is accessible. And we have local variables and global variables. So as the name suggests, for local variables, they are defined within a function and are only accessible within that function. Okay, so it's just inside the function and not outside of it. But global variables, they are defined outside of any function, and it can be accessed throughout the entire script. To just explain these, here we start by assigning value 1 to this variable out. And because this is outside this function, this means that from now on, whenever we use out or call or print out, its value is 1, right? So this is a global variable. However, if we look at this function, right, so we want to add two numbers, a and b. So we add a and b together, and then we assign the result to this variable out, and then we want to return this. So this out that you can see here inside this function, this is a local variable. And Python is very smart. Python, it is not going to use the same place in the memory for these two variables. So they do not interfere with each other. So this means that even if I have, like, let's say a and b, one to be 1 and the other one 2, so 1 plus 2 would be 3. That value 3, which will be assigned to the out inside this function, will not impact the value of out in the outer part of this function, right? Because they use separate memory blocks. To just prove that that's the case, what we are doing here, we are using this print statement inside the function, right? So this means that now when I call add numbers 1 and 2 here, first we're going to this function and we're going to print this statement, whatever the value of out is. And once we are done with this function, we are going to again print the value of out, right? But remember, this last print that we have here is going to print the global value of out, not the local one. So if I run this cell, you can see that the first print, which is the one inside the function, gives me the value of 3, and that's what we expect because you're adding 1 and 2, so it's 3, and the 3 was assigned to the variable out inside the function, so that's the local variable. However, for the second print statement that we have, you can see that this is the global value of out, and that's 1. And this is something, again, possible because Python is not going to share the same place in the memory for both of these variables, even though they have technically the same name in this case. So we have explained this here in text because this is something very important. And remember, this is mainly because the memory block is distinct from the memory block where variables outside the functions are stored, right? So when you define a function, it's going to use a distinct or separate memory block, so it does not interfere with global variables. And just again, to prove that this idea of local and global variables, right? So we call this function in this line where we said d equals at numbers 1 and 2. So we went through this function once. So you may expect that, well, then a should be defined, right? Because I assigned the value 1 to a. But remember, this a is local variable. So if I just, in general, like outside this function, put print a, I get this error message that a is not defined, right? And it is true because a is only defined within this function that I'm highlighting, right? So it's just a local variable, it's not a global variable, and you cannot use it as a global variable. So that's something very important about the scope of a variable. Okay, so now let's talk about nested functions. So nested functions in Python refer to the concept of defining one function inside another one. And in this case, you can think of having an outer function and an inner function. And the nice thing is that the inner function has access to the variables and the scope of the outer function, right? So you can notice the hierarchy here. And this is very helpful, especially for functionality and maintaining a modular structure. So let us, for example, here define a function which is called outer function so that we know it's actually an outer function. And now we have two inner functions. This function that finds the squared value and the other one that raises x to the power of 3. So in this case, I do not need to explicitly pass this x to these inner functions because x is the global variable inside this outer function. And you can see that in this case, I just call a square with parentheses, but nothing inside it. And I assign the result to result underscore a square. And the same thing with cube, result underscore cube. And then I'm returning these two, right? So in this case, it is just enough to give this value of 4 to the outer function. And because this x here, which is now 4, is global for these two inner functions, so you can see that we are able to calculate the square value of 4, which is 16, and also the cubic value of 4, which is 64. But what do really we mean by maintaining a modular structure? This is something very important, especially when you focus on more advanced programming topics. So let's say we have a set of three-dimensional data points. So it's a 3D space, you have X, Y, Z coordinates, right? And let's say you want to write a function that calculates the square differences between each of every two coordinates, right? So X and Y, X and Z, Y and Z, right? So one way to do this is just saying that in order to find the square difference between X and Y, find X minus Y, raise it to the power of 2, right? And similarly for X and Z, subtract X and Z and raise it to the power of 2. And the same thing with Y and Z, find Y minus Z squared. But as you can see, this is really boring and really waste of resources, right? To repeat this again and again, right? So one thing you can do, you can define this inner function, which is called find a square difference. And this accepts two input arguments, subtract them, and raise it to the power of 2. Because this is an inner function and x and y are local variables inside that function, so this means that I only need to define this operation once, and later on, I can call this function that we have here 3 times. One time I pass x and y, the other time x and z, and then the other time y and z. And again, this is something we can do because the x and y that we have inside this inner function will not interfere with global variables that we have in our outer function, right? So there's no overlap or interference here. And also this gives you a lot of functionality and modularity here, which is really helpful. So you can see that once we define this function, let's say you have a data point, 3 coordinates, 2, 4, 7, and you call your function. And in this case, you can see that we get this result. Recall that this is a tuple because of these parentheses that we have. And so the first element should be 2 minus 4, which is negative 2 raised to the power of 2, which is 4. And then 2 minus 7, which is 5, or negative 5, and raised to the power of 2, which is 25. And then 4 minus 7, which is negative 3, and raised to the power of 2, which is 9. So that's, you can see how this works. Now let's talk about lambda functions. So lambda functions, as we said, are anonymous functions, and they're very interesting, actually. So defining a function in the conventional way, sometimes it's not optimal because we may have like a relatively simple function, which is like 1 or 2 lines, typically just 1 line. And in such cases, you just want to perform that operation and you don't want to assign a unique name to that function. And you can do this using the lambda keyword instead of the def or def. So the way that this works is very simple. Use the lambda keyword, use all your input arguments, colon, and some expression. So this is what you're trying to do with those input arguments. To just explain this and how simple it is, so let's say you define a function add, it accepts 2 input arguments and returns the sum of the 2. So this is something obviously possible because we do not have to assign x plus y to another variable and then return the other variable. You can just write this in 1 line. So in this case, we can have this equivalent lambda function, which we use lambda keyword. X and y are the input arguments, colon, and this is what we're supposed to do with those 2 input arguments, which in this case means that we want to add them. And in this case, if we run the 2 functions or call the 2 functions and compare them, you see as expected, we get the same result. However, something to keep in mind is that these lambda functions can be extremely helpful for solving a lot of scientific computing and data science problems. One of them is, for example, the problem of root finding, right? Meaning that if, let's say, we have this quadratic function, f of x, ax squared plus bx plus c, right? So a and b and c are constants. So these are the constants you have in your polynomial function. And you want to find the root of this function, meaning that for what values of x, we get f of x equals 0. So one way to solve this problem is to use a library called SciPy, which is like NumPy and other libraries in Python, but it's specifically designed for some of these like scientific computing problems. And inside this library, we have something called fsolve. And what this does, you can go through this documentation page and learn more about it, but it returns the roots of nonlinear equations defined by some function of x equals 0. And the way that this works, it needs a starting point or estimate. So you provide an initial guess, and this fsolve here is going to try to improve that initial guess and give you a solution in a sense that some x value such that f of x equals 0. So how this works with lambda function, so in this case, you can use lambda function to define this polynomial function rather than just calling it some name and use the f keyword. You can just use a lambda function. To show you this, let's say we import numpy as np, and we said that we need to use scipy. So one way to use this is saying that from scipy that optimize import this fsolve. So this is what we just talked about, finding the roots of nonlinear equations. So in this case, let's say the polynomial that you have is x squared minus 4, meaning that if I compare this with what we have here, a is here in this case is 1, b is 0 because there's no x, and c is negative 4, right? So in this case, we provide a, b, and c using this Python list, right? 1, 0, negative 4. And then in order to define the polynomial function, we just use the lambda keyword. So we say lambda of x, so x is your input, is the first element of this list, which is the a here, which is 1, times x squared, plus the next element in this list times x, plus the third element that we have, right? So these are the a, b, and c. So it's ax squared plus bx plus c. And also you need some initial guess. So let's say, in this case, we think 5 is a good initial estimate. And then what you do, use this fsolve. And the first thing is that you have to provide the function that defines, in this case, your polynomial. And we are using this lambda function that we have. And then the initial guess, and this will do the magic and will tell you the root of this polynomial, which is 2, and it is correct, right? Because if I substitute 2 in this polynomial, I get 2 squared minus 4, which is 4 minus 4, and that is actually equals 0. So you can see that we get the correct root of this polynomial. So something I think would be fun to do is to use different initial guesses and see whether you can find the other root of this polynomial, right? Because note that if x equals -2, then you get -2 squared, which is 4, and then 4 minus 4 is 0. So see if you can change this 5 here and find the other root of this polynomial. And now we have the homework problems for this lecture. Something to keep in mind is that for this homework problem that we have, make sure to use appropriate docstrings. I do prefer multi-line docstrings where you provide some details, what are the input arguments, what are the output parameters, and you explain all of those in the docstring. And then we have really interesting problems where you work with NumPy arrays and you also define functions that they operate on them, and also functions that operate on Python lists, etc. And also you get to use a few more built-in Python functions such as sorted and filter. So the idea here is to build on what we have learned in the lectures and expand our knowledge. I hope you find this video helpful, and please let me know if you have any questions.